Here's question 8, have a go. So for part A we need to differentiate, so multiply out to allow us to do this, so we get y equals x cubed plus 2x squared, and then when we differentiate we get this, so nice easy 2 marks. Now for part B we need to sketch this. Well, look back at the initial equation before we multiply it out, and we're going to get it's a cubic because we've got an x cubed, so it's going to be looking something like this shape, with this way round, given it's a positive x cubed. Now what we're interested in is the solutions where it meets the x-axis. Now this is effectively x times x times x plus 2, so we've really got a double tap effectively when x is 0, so we know as it meets this point twice, 0, 0, that is the one where it meets the x-axis but doesn't actually cross the axis. And as I said, that's because it's really a double tap at that point, because it's x times x again. Our other solution was what makes this bracket equal to 0, so x being minus 2, so that's the shape. Now we need to find the gradients at these 2 points, minus 2 and 0. We find a gradient by substituting in the appropriate x value into our differential, into this. So at 0, 0, when we substitute 0 into this, we get a gradient of 0. And at minus 2, 0, we substitute minus 2 into the differential, into this, which we've done over here, and this gives us a gradient of 4. Now for part D we need to go back to remembering how we do transformation of curves. We are effectively taking away k from each of these two terms up here, aren't we? Instead of x we've got x minus k all squared. Instead of x plus 2 we've got x minus k plus 2. Now remember, if it's within inside the bracket it affects the x coordinates and it does the opposite to what you would affect. So this is just going to shift the curve by plus k to the right. Now we're told that k is greater than 2, so taking this point here it's going to shift it to the right more than 2. So we basically can shift this one over here to more than 2. So basically that point becomes minus 2 plus k 0 as a coordinate, and the 0, 0 becomes k 0 as a coordinate. Now we do need to see where all the points where it meets the x and y axis, and because we've shifted across this tail bit here, this is now going to be crossing the y axis at some point. That's crossing here. Now that's crossing at when x is 0, so substituting 0 into this formula, what do we get when we substitute 0 into this? We get this, we're left with minus k all squared times minus k plus 2. Multiplying that out we get the coordinate minus k cubed plus 2k squared. So this coordinate here is 0 along the corridor, minus k cubed plus 2k squared down the stairs.